Okay, first of all, you'd want to read your directions because number 1 says write a system of equations and do not solve. So all we're doing is setting up a system of equations, and what that means is finding the 2 equations out of the word problem. Alright, so let's go through and find our data. Here's a piece right here. We've got $5 for adults and $3.50 for students. If 470 tickets were sold for a total of $1,900, how many adult and student tickets were sold? Alright, so we want to kind of come and say, let something be something. So let A equal adults, and let S equal student. I don't have my stylus. I'm writing with my pencil. I'm struggling. My hand. I'm sorry. I'm struggling. Alright, so let's set up our equations. So I've got this piece of information, 5, and that's for adults, so 5A, and $3.50, so $3.50, S for students, and I'm dealing with many, so that's going to come match back up here with money, so that's $1,900 here. And then I know that if 470 tickets were sold, what combination of things makes up my 470? And that goes back to my adults and my students, and that's adults, a combination of adult and student tickets equals 470, and those are my 2 equations for that one. Alright, so number 2 is also just setting up the equation. So it says find the value of 2 numbers, and if their sum is 12 and their difference is 4, and I'm going to let x be x in this case because I don't know what the 2 numbers are, and I'm going to let y be y. Alright, so find the value of 2 numbers. I know I have 2 numbers of x and y, and their sum, I know that means that they're added together. And is a very important word here because I know that always means equals. Is 12. That's the first equation. The second one is find the value of 2 numbers if their difference is 4. So I know I have 2 numbers of x and y, and it says their difference, so I know that's subtraction. That's a key word there. Is, that always means equals. Their difference is 4, and there's your 2 equations there. Okay, number 3. As we read, we're going to go ahead and underline all the important information. Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Alright, so I'm going to let X be small boxes, and I'm going to let Y be large boxes. X and Y, that kind of looks like, there we go. There we go. Looks more like a Y. Of oranges. Alright, so we're dealing with small boxes and large boxes. Matt sold 3 small boxes of oranges and 14 large boxes of oranges for a total of $203. Ming sold 11 small boxes of oranges and 11 large boxes of oranges for a total of $220. Find the cost of each of 1 small box and 1 large box of oranges. Alright, so let's start setting up our equations. Alright, so let's deal with what Matt and Ming did. Matt sold 3 small boxes. Oh, sorry. And he sold 3 small boxes and 14 large boxes. I'm going to do an L in cursive so it doesn't look like a 1. And that was for a total of $203. And then Ming sold a total of 11 small boxes and oranges and 11 large boxes for a total of $220. Okay, so here's our 2 equations, and now here's where you would, I would really hope that you would have your calculator right now and you would put into the matrix to have your calculator solve it for you. So maybe I need to find some kind of YouTube video, or I need to make a video of me doing that. But these are the equations you're going to put in, and hopefully you are just putting this into your calculator, and I will post a video of that later. Okay. Alright, at Elisa's Printing Company, LLC, there were two kinds of printing presses. Model A, which can print 70 books per day, and Model B, which can print 55 books per day. The company owns 14 total printing presses, and this allows them to print 905 books per day. How many of each type of presses do they have? So I'm going to let Model A be my X, Model B be my Y. Model A can print 70 books per day, and Model B can print 55 books per day, for a total of 905 books a day. The company owns 14 total printing presses, so I know the number of Model A's plus the number of Model B printing presses that they have equals the 14 number of total printing presses that they have. There's your two equations for that one. Okay, a class of 195 students went on a field trip. They took 7 vehicles, some cars, some buses. Find the number of cars and the number of buses they took. Okay, so once the two things that we're dealing with are cars, so let's let C equal car, let B equals bus. Okay, they took 7 vehicles. So I know they took some cars and some buses. Find the number of cars and the number of buses. If each car holds 5 students and each bus holds 45 students. So we're going to go with 5C plus 45 students on the bus, and they hold the total 195 students. So there's your two equations you put on that one. Alright, there were this many tickets sold to Carolina Panthers football game. Adult tickets sold for $30 each, and student tickets were sold for $24 each. This total dollar amount collected from the ticket sales was this much. How many more adult tickets were sold than student tickets? Alright, let's let A equal adult tickets, and let S equal student tickets. And it says here that the adult tickets were $30 each, so 30A, plus student tickets, which were $24 each, and the total of tickets sold was in the millions. I'm going to put this guy right there. Okay, and then it says that there were 58,389 tickets sold, and that would be the combination of adults and student tickets. Carton contains a total of 40 books. The number of paperbacks is 5 less the number than twice of the hardbacks. How many hardbacks are there? Okay, so I know that there are a total of 40 books, and I'm going to let P be paperback for my X's. I'm going to let H be hardback for my Y's. So a carton of 40 books, And I know there are paperbacks and hardbacks, so a combination of paperback and a combination of hardbacks makes my 40. The next one's a little more tricky. It says that the number of paperbacks is, and here's my key term right here. So the number of paperbacks is 5 less than twice the number of hardbacks. So 5 less than, I need to be subtracting something from it, twice the number of hardbacks. So 2h. So there's my equation on that one. Alright, the points -10, 15, and -15, -10 both lie on the graph of a linear function. Another set of points at -1, -3, and 6, 4 both lie on the graph of a linear function g, which point lies on both graphs. Alright, anytime you see the word both or when are they the same or something like that, then you know you're going to set two things equal to each other. And I realize that really the only information given are 2 points, and I know what I can do with 2 points. And if it's looking for 2 points and a formula, I'm going to plug those 2 points into my calculator and solve for the linear, just for the formula, the line of the formula. Y, put it in y equals mx plus b. So I'm going to put that into my calculator under stat, edit, calc, number 4, lin reg or something like that, and I'm going to get 2 equations. So I'm going to put the -10 in my L1 category, and then -15 in my L1 category, and I'm going to go over to my L2 category and put a 15 and -10 and clear out and go back in, and I'm going to get my 2 equations, and I'm going to set them equal to each other, and I'm going to put those down right now. Okay, so here's the 2 equations that I got from my calculator, and now I just need to solve for x. So I'm going to move this 1 over here, this 1x, by subtracting to keep my x's over here on the left, and that leaves me with 4x. That canceled out, so I've still got that -2 over there. Now I'm going to move this 65 over here. And that leaves me with 4x is equal to -67. Divide both sides by 4. And x is not going to be pretty. It's going to be 16.75. And then if you plug 16.75 back in for your original equation right here, x minus 2, so 16.75 minus 2 is going to give you 14.75. So which point lies on both graphs? Your answer is going to be 16.75, comma, 14.75. Alright, this summer a merchant sold souvenir pens for $7 and glasses for $9. Sales for these 2 items were a total of that. Last summer, the sales for the 2 items were a total of that. Pens sold for $5 and glasses sold for $6. If the same number of each souvenir was sold both years, which system of equations, linear equation models this situation? So again, anytime it says if the same number of souvenirs or anything like that, we know we're going to put those 2 equations equal to each other. Alright, so let's come down here, and A does have 2 equations that are equal to each other. Let's take a look at some of the data and see if it matches up. Looks pretty good, but I want to double check and look at some of my other data. Let's take a look at B. It says here 11x y equals 4,540. Like, I don't even know where that 11's coming from up in the problem. Like, I don't add anything. That's probably not my best bet right here. We're going to mark B out. Alright, taking a look at C. I've got x plus y equals z. I've got 12. I've got a 15. I don't even see any of my right numbers that I've gone up here and I've circled. I've got a 5, a 7. I've got a 9. I don't have any of that in there, so I don't think that's a good answer either. And then I've got this 11 distributed onto an x, y. That looks like a hot mess, but let's go back up and double check what's going on in A up here. I have 5x plus 6y. Here I've got pens are sold for $5 and glasses are sold for $6. That's good. That's a good formula. And they were sold for 4,540. That's a good formula. And then here we've got glasses were sold for $7, check that year, and $9, or pens were sold for $7 and glasses for $9. They were sold for a total of 6,560, check. All right, we know that's a good answer. All right, the perimeter of a rectangle is 40 feet, and anytime I have any kind of problem like this, I always just like to draw a rectangle just to visualize it. The length of the rectangle is twice the width. Write a system of equations that you could use to find the length and the width, where length is the length and W is the width. Alright, so I guess I would need to know that perimeter is when I add everything up. So it has a perimeter of the rectangle is 40 feet. And it says the length of the rectangle is twice the width. So I have a length that's twice the width, and I know that perimeter, I'm going to have 2 of my lengths and 2 of my widths. I'm going to add up because that's what perimeter means. So I'm going to have 2 lengths and 2 widths added together, and that's going to give me my perimeter, and it already gave me my perimeter, which was 40. So those are the 2 equations we're looking for. So taking a look at A, it says width equals 2L, and that's not true, because if you look back in here, it tells you that L equals 2W, so that's not a good one. L equals 2W, that's good. But L plus W equals 40, and that's not true, because that would just be this side plus this side, and that would only be 20, I guess. And then L equals 2W, that's good, but LW equals 40. Length times width would give you the area and not the perimeter, so that's not a good formula there. And then you'll see those 2 match up, so that would be the correct answer.